Good morning, this is Kavipriya, Assistant Professor EC Department. I am going to discuss about the topic Zener diode. My flow of presentation is what is the basics of Zener diode and what is the need, introduction to the Zener diode and working and biasing of Zener diode and what are all the breakdowns that occurs in a Zener diode and finally what are the applications of the Zener diode. First, what is the need for the Zener diode? So, for wherever the voltage regulation is required, we go for the Zener diode. And Zener diodes are simply useful for the over voltage protection and for clipping a certain part of the waveform from the entire waveform. And wherever the meter protection is required, the Zener diodes are widely used. Zener diode normally behaves like a general purpose PN junction diode and for biasing in case of this Zener diodes can be a forward bias and operates in a favor forward bias and also it operates in a reverse bias conditions. The main specific characteristics of the Zener diode is that in reverse bias condition it will be providing a constant reverse bias voltage. And biasing in case of Zener diode, it is of two types. One is a forward and second one is a reverse. In forward bias condition, positive of the battery will be counted to the anode and the negative of the battery will be counted to the cathode. So in case of forward bias condition, Zener diode behaves exactly like a PN junction diode. So there will be a gradual increase in the current within the gradual increase in the voltage. Once a threshold voltage is being reached, there will be a rapid increase in the current. So, in case of the reverse bias condition, the Zener diode acts as a voltage regulator. When a reverse voltage is applied up to a certain voltage called breakdown voltage, there will be a gradual increase in the current. Once a breakdown voltage is being increased, there will be a rapid increase in the current. Our voltage is kept as a constant. So this is the VI characteristics of the Zener diode. In case of forward bias condition, there will be a gradual increase in the current whenever the voltage is being increased up to a threshold value. The threshold value ranges between 0.3 to 0.7. Once a threshold value is being reached, the barrier between the P and N type junction, P and N type material will be completely vanishes. It results in a recombination of holes and electrons. More electron and hole pair will be created, which results in a rapid increase in the flow of current. In case of the reverse bias condition, there will be a gradual increase in the current up to a Zener breakdown voltage. Once a Zener breakdown voltage is reached, there will be a rapid increase in the current, whereas the constant Zener voltage is being maintained. And we have two breakdown mechanisms in case of a Zener diode. First one is Zener breakdown and second one is a avalanche breakdown. Zener breakdown happens in a heavily doped PN junction where electric field in the depletion region is very strong. Avalanche breakdown occurs in a lightly doped PN junction where the depletion region is very wider. And next is the applications of the Zener diode. It is act as a regulator, comparator, limiter and it is widely used in the power supplies. And next is the advantages and the drawbacks of the Zener diode. So as like a PN junction diode, the Zener diode is very simple and it is more cost effective and it can operate even in the reverse bias condition. It provides a low forward voltage drop. Drawbacks are noise generation is the main drawback of this Zener diode and it has a dynamic resistance is required to avoid the overflow of current. And next is the assessment questions. Zener diodes are also known as a breakdown diode. And next is which of the following fact is true about the resistance of the Zener diode? It has an incremental resistance. It has a dynamic resistance. The value of resistance is the inverse of the slope of voltage current characteristics of the Zener diode. And next is that which can be used in a series when Zener diode with the Zener diode so that the combination has almost zero temperature coefficient. The options are diode, resistor, transistor and the MOSFET. Whereas when diode is used as in series with the Zener diode, the combination has a almost zero temperature coefficient. So that's all about the topic called Zener diode. We have discussed about the basics of the Zener diode. We have seen what is a Zener diode and where this Zener diode is being used. What is the need for the Zener diode? And later we have discussed about the construction of a Zener diode, and we have discussed about the operation of the Zener diode. And finally we have discussed about the applications of the Zener diode. Thank you.